in the second part, let's explain the mechanism of the radiography machine and mammography machine. We explained the basic physical principles of X-ray imaging, and now we will go through the radiography imaging machine. The first type and the modality of the X-ray imaging is projection radiography. It's called projection radiography. This is the image of the machine. Mostly, the appearance is same. There is a stand here and the X-ray source on the top. And you can see the operator try to adjust the MA and KV and the exposure time. These three main parameters are important. Depends on the patient size and where the operator wants to image, which organs. So the protocol of imaging, including KV, MO, and time, is designed, and the position in terms of vertical position or horizontal position is tuned as well. The patient lay on the table, and under the table here, you can see the sensor, the detector, which is beneath the patient. And this is the configuration of planar or projection radiography. Planar or projection radiography. After the operator adjusts the protocols, we go outside the room, not inside the room, because the X-ray is harmful. He or she go out of the room, and there is a key or a button or a pedal, foot pedal. When it is pushed, the X-ray generated here in the X-ray source and then passed through patient, and we have image. There is some tools to do the imaging process more precisely. For example, there is a light lamp inside, in the top after X-ray source to show where the X-ray beam will be hit the patient body by using light, because it's very important to minimize the area of X-ray to the patient and precisely adjust the position. Minimize because we should intend to minimize the X-ray photons that go through the patient because it's harmful, and very precise, because if you cannot precisely locate the position of X-ray after seeing the image, maybe you find out that this is a wrong place, and you should repeat the scanning. And repeating the scan means higher X-ray photon using for one patient and one exam. So it's very important to see where you are going to do the examination by using a light. But as you can see, we have a two-dimensional 2D image of a 3D object, yes? Our body is 3D. We have the X, Y, and Z direction points, but we have two-dimension image. It means that the information from different layers of patient body superimposed together and make a two-dimensional image. Because of that, we call it projection radiography. Projection radiography is some kind of imaging of three-dimensional object to two-dimensional image. It has, some advantage and disadvantages. Main disadvantage is you can see all the information in different depths of the patient body just in one image. For example, you can see the spine. At the same time, you can see, for example, the abdomen organs, and everything superimposed in one image. This is the disadvantage. But the main advantage is the imaging process is very fast, is cheap in terms of the money which patients should spend, and the X-ray radiation is low, for example, compared to more sophisticated machines like angiography and CT scan. So it's fast, low radiation, and in terms of financial and the money and payment, it's cheap compared to other machines. We call projection radiography. Different organs can be imaged. For example, here we have the image of the abdomen and some parts of pelvis. And here the image of, for example, hand. Again, we have X-ray source on the top, a panel to adjust the protocol, and a handle that, adjusts the position of the X-ray source, the patient body, and under the patient body we have a receptor. We cannot say exactly it is a screen film or detector because the appearance is very, very similar to each other, but inside this slot, you can see there is a slot here. Inside the slot can be a digital detector or a screen film. If we have a film, after exposure, we should take out the screen film and go to the dark room to, by a chemical process, form the image in the film. In the digital, there is a cable here connected to the detector, go to the computer, and directly and immediately after the exposure, we can see the images in the computer. As I said, X-ray techniques, factors is important, applied KV, MO, and exposure time, and based on the organ and the application and the patient size, it should be appropriately adjusted based on the patient or organ of interest. There is one fact which is very important, is geometry of the X-ray imaging. Geometry of the X-ray imaging. We have very small point inside the X-ray source on the anode surface, which the accelerated electron hits that point, and from that point we have a generation of the X-ray photon. And so we have very small points here, which the photons come from that. And after we have an opening of X-ray beam, it is the size of patient and it is the size of image. So we have somehow a magnification. Like the size of the shadow of my hand, when I increase the distance between the object and the screen, the size of the image will be magnified. We call it magnification. So the magnification depends on the distance between X-ray source to patient and patient to the detector. It's very important. The equation is very simple. We had in the high school in the triangle geometry. The magnification defined as image size compared to divided to object size. My equation is A plus B over A. A plus B over A is the Thales theorem, very simple. So why it's important? Because sometimes you need to magnify a very small area of the patient body to see it precisely, to look at it by, better resolution, better fine changes inside the body. So, another parameter added to KVMA and exposure time is the geometry. The geometry which is used to optimize the image quality, because by increasing the magnification, you will change the image quality, mostly in terms of resolution. As I explained, we have screen film. In radiography, we have a screen film as well. Mostly in radiography, was very common around the world, but newly machine is mostly digital, but the screen film more than 30 or 40 years in the world is used. In the radiography machine around the world is very important. Many companies around the world was manufacturing their screen film, like Kodak. Kodak is very famous company which design and manufacture the screen film for medical applications. Different kind of silver halide and very high technology methods of intensifying and amplifying the number of photons, increasing the sensitivity, very long history of technology improvement and developments in the screen film. But at the moment, I can say that the screen film history is going to be finished and the digital era is coming. It's the cassette which is normally used in the screen film method. There is a sheet of film, there is something like a book, and in the dark room, the room should be dark, the film taken from the pocket and put inside the cassette. We have two screens in the top and the bottom, and then we close the cassette and lock it. There is somehow the manufacturing and the design is somehow there is no leakage of the light, no light coming from outside to inside, because this film is very sensitive to light, normal light, and if there is a light leakage, it means that any photons that come from outside to inside of the cassette will destroy the film. So this lock and the design is very important. After closing the door of unlocking it then take and put inside the slot Venice under the patient body and using for scanning. One question arises at the moment, how this light photons, which is generated from X-ray photons, is hit that film, sheet of film. Here you can see two different kinds of screen film. The first is a screen film with a thick screens and a screen film with thin screens. The same film, you have same film, but the thickness of the screen is different. If you remember, here I explained how the screen works. One photons come and doing interaction inside the screen. For example, the point of interaction is here. And after that, we have generation of visible light here. The advantage was intensifying. But what about disadvantage? The main disadvantage of this mechanism is losing the resolution. Why? Because if we don't use the screen and put the film here, one photon made one small point in the film. One photon made one small point in the film, it is good. But here, one photon with a small point of interaction made a very large point here. We have somehow a distribution or a spreading of this point to very large point. It is not good. Each photons make a large point. It means that we are losing, and the resolution is going to decrease. Resolution means seeing the fine detail in high quality fashion. Okay, is the resolution. But here, to a small point converted to large area, for example, circle. It means that we are going to decrease the resolution. How we can decrease these disadvantages? By decrease the thickness of a screen. Here you can see one photon come here, there is a distribution of light, and the size of this light effect is large. But when you decrease the thickness of the screen, there is less spreading of the light, so less miss effect of resolution, or we have better spatial resolution, better resolution when we have thinner screen compared to thicker screen. What is the applications? For example, in mammography, one of the symptoms of the cancer is very teeny microcalcifications inside the breast tissue. Very teeny microcalcification. Some, colony of the calcium atoms and make some, very small dots of calcium. We call it microcalcification. It's very important in mammography imaging. We see these very small calcifications. So we need high resolution imaging. For high resolution imaging, it's better we use a thin screen, because thin screen make less light spreading and make better spatial resolution. But according to this formula, please answer my question. According to this formula, if we decrease the screen, what will happen? Is it good for photoelectric interaction or not?
Yes.
If we use thin screen, if we decrease the X,
Is it good for what?
if we decrease the X,
There will be a spread.
is the number of photons that it detected in the screen increase or decrease? If we decrease this thickness, the number of photons that have the chance of interaction inside it increase or decrease? If we decrease the thickness of screen.
Like the transmitted number of photons will
Yes.
decrease.
And the number of photons which do interaction inside.
Will increase.
Increase.
The one inside will increase and the one back.
Inside increase, why?
And will
Decrease or increase? Increase.
And will increase. And
And what about this? Which one absorb more photons? This one or
the
this?
thick screen will absorb more photons.
This absorb or this? Right or left?
Left.
Left,
Yes.
more absorption. This one, less absorption.
Yeah.
And absorption means detection, because it is detector. We need to absorb more photons by detector, because every photon which is absorbed by detector is information, more information is collected by the detector. We need to collect all photons that come from the patient body, because all of these photons are information. Why we use the screen? Because the film has very thin thickness, and most of photons, X-ray photons, pass through it, and most of the information is missed. Yes, we add a screen because we want to absorb more photons, because all photons have information. If we increase the screen, more photons will be absorbed, more information will be collected, and the image quality will be better. But by increasing the thickness, although we have more absorption, but due to the spreading of the light, we are losing the resolution. So there is a balance between how many information I'm gathering and what resolution I need. In mammography, the resolution is preferred. The resolution is preferred. So we use a thin screen, although we lose some information because of thin screen, but as the spreading of light is low, the resolution will be better. In radiography, normal radiography, the information is preferred to resolution. So we use thick screen due to this equation means higher X mean
More absorption.
more absorption, so more information in the image. This is because we have different type of screen field in different machines. We have the same reasoning in the digital detector. For example, in mammography, we need high resolution digital detector. In radiography, we need high absorption digital detector, and it depends on the machine. Okay, I think the time is finished because we have a bus. We have a bus at 12.
Yes.
Okay, we will continue tomorrow. Any question?
No, thank you.
Thank you. I want to share some video for you. How can I send to you?
If you want, you can put them on the computer, on the desktop, and I'll take them on my phone and I'll share them to everyone.
Can I send you by phone?
Yeah, sure.
Or do you have, where can I send you?
WhatsApp, Telegram,
WhatsApp,
email.
Telegram, email. Okay. Do you have Dropbox as well?
Dropbox? No, I don't, because it's one. It's only.
Oh, it's very good, I think. I will send you an email
Okay.
and Dropbox invitation. Go to the Dropbox website. By your Gmail, for example,
Yes.
you can have accounts inside. And then download the Dropbox. It's completely free.
Okay.
Download the Dropbox. When you download and install the Dropbox, in your My Computer, you will see a new folder called Dropbox. Everything I copy on the Dropbox, you can see.
Yes.
And we can, communicate by Dropbox.
Sure.
Just send me your email